Today we'll be talking about what we have learned in 4AC, and I'll be talking about, excuse me, sorry. So I'll be talking about I'll be going through what RC circuits are and what does transient RC circuit means. So what are RC circuits? RC circuits are actually put in an easy way, a circuit that consists both resistor and capacitor circuits. Then you might ask, what's the purpose of having this kind of circuits? The purpose of RC circuits actually is to either discharge or charge a capacitor. When you're using a direct current or in short DC, capacitors are actually like an open circuit. However, if you use alternating current, which is AC, currents and voltage are always are changing continuously, and so the capacitors are charging and discharging continuously also. Then I'll move on to transient. So what's the meaning of transient, you might ask? If you look it up in the dictionary, transient actually means over a short period of time. So if you apply it into the circuit, it means that in both cases, the quantity of charge that collects or leaves the plates of the capacitor, the quantity of electric current that flows in the circuit, and voltage difference that exists across the capacitor varies with respect to time. So I'm just going to show you what I have drawn. So this is like a simple RC circuit that is not charging or discharging. However, when you move on to charging circuit, so this is I replace here the current, the switch, sorry. So this is actually how you draw the, oh yeah, before I move into that, here's how you find the time constant. Is where your resistor times your capacitor, ohms and in farads. So this is how your capacitor voltage will look like when it's charging, and capacitor current when it's charging. So actually we only draw until 5 tau because supposedly that's when it stops charging or discharging. So now move on to discharging circuit. Discharging circuit, as you can see, the difference is that here the supply becomes short circuit, and then when you close the switch, it's actually discharging throughout. So this is actually how your graph will look like. And here are the formulas that we use to calculate the values. This is for charging and this is for discharging. So now I'm going to pass it to Zhen, and then she'll talk about and compare the difference between an RC circuit and an RL circuit.
Now I'll be talking about the RC transient circuit versus the RL transient circuit. So transient basically means a momentary variation for current or voltage. RC circuit is basically resistor capacitor. So in a circuit, there is a resistor and a capacitor. The capacitance is basically the ability of the plates to hold a certain amount of charge for a given voltage, and the voltage calculated in the plates is basically the energy stored between the plates. Capacitance is measured in farads and is based on the area of the plate and the distance between the plates, which is very, very different from inductor. The RL circuit is basically the resistor inductor circuit, which means in a circuit, as you can see over here, there is a resistor and an inductor. The inductance is calculated by the magnetic flux created by the coil for a given amount of current. So it's very different from RC, which is between the plates. Now inductor is among a coil. The energy calculated for the inductor is basically the energy stored in the magnetic field within the coil, and it's measured in Henry. And inductance is based on the coil's geometry, like the loop's length and the cross-sectional area. So it's very different from RC. As you can see over here, the charging capacitor and inductor is complete opposites of each other. For capacitor, as tau increases, the current decreases. For a charging inductor, as the tau increases, the current also increases. The formulas to calculate both currents is also different. For capacitor, current is calculated by current times e to the power of negative time over resistor times capacitor, while for a charging inductor, current is calculated by I times 1 minus e to the power of negative time over inductor over resistor. The tau calculated for both is also widely different. Tau for capacitor is calculated in resistor times capacitor. Tau for inductor is calculated by inductor over resistor. A capacitor sine wave. In a capacitor sine wave, current leads voltage by 90 degrees, while inductor is a total opposite, which means current lags voltage by 90 degrees. That's all for RC, the difference of RC versus the RL transient circuit.